Hi friends, welcome to our channel Jayaditya Math Tutorial. We are doing a series of Ncert class 11th mathematics. As a part of this, we are now in the chapter sets. In our previous class, we have discussed the exercise problems of 1.2. All the problems are related to equal sets most probably, and some problems in the previous class also we have discussed some problems like the sets which are finite sets, which are infinite sets, and we have also discussed the concept of null set or void set or empty set, like that. So if you don't watch my previous classes, please do watch them, then you will be having a clear idea about this class. And class we are going to discuss about some other important concept, that is subset, which is very important. So please do watch this class till the end, and if you are new to my channel, please do subscribe. If you like my class, please do like and share with your friends, and don't forget to hit the bell icon. So without wasting any time, let us enter into our class. Let us have a look at the situation here. Let X be the set of all students in your school and Y be the set of all the students in your class. Okay, so this is a situation where you have two sets. What is about first set? That is set of all the students in your school, complete school, and Y is the set of all the students in your class, just in your particular class. So what can you say about X and Y? So see here, if you observe the students of a class, the students of a particular class are also present in the school, right? Are also present in the school. That means each and every student of a particular class is a student of the school. Clear? For suppose, let us say your school is X, okay, no, and you are studying Yth class, okay? So the student of Yth class is nothing but he is also the student of X or not. So every student of class Y, is belonging to the school, right, Nana? So what can you say here? Each and every element, that means here each and every student will be an element, right, Nana? So each and every element of Y, that means student of a class, is also present in the set X. Clear now? So what can you say about X and Y here? That is very simple. That is nothing but Y is a subset of X, Nana. Y is a subset of X. Why? Because each and every element of Y is present in X. Each and every element in Y is present in X. That means each and every student of a class is also present in the school. Okay, Nana. So symbolically, how do you represent this one? That means, see here, so Y subset of X. So this symbol is known as, the symbol we will be used to show that a set is a subset of other set. So this symbol is read as is subset of, and also it can also be read as is contained in. So you can read in any manner, but mostly we will be using only the first case. So how to read this one? Y is the subset of X. So Y is a subset of X. Y is contained in X. Y is contained in X. That means all the elements of Y is present in X. Clear? So whenever the situation is like this, that means each and every element of a set is present in the other set. Therefore, we can say that Y is a subset of X. Clear? So what can you say about the definition now? For example, A and B are two sets. For example, you take A and B as two sets. So if each and every element of set A, is present in B, then we can say that A is the subset of B. So a set will be subset of another set only if each and every element of a set is present in the other set. So in the way of definition, so you can say like this now. Okay, this is all about your subset and its definition. So let us see some examples and let us discuss about subset in detail. So A will be subset of B if each and every element is present in B, right now. So in other words, how can we say this one? So A will be subset of B A subset B if whenever A belongs to A, then A belongs to B none. So that means you see here, for example, if A is the set and B is the other set, A is subset of B none. A is subset of B, that is the condition given. So that means, see here, if whenever A belongs to A, so here I am representing it with small letter. Small letter in the sense, what is it? That is nothing but element, right? So if an element belongs to A, we know that this symbol is nothing but is belongs to. If an element is belongs to A, then what can we say about A, Nana? So A will be automatically, that will be the element of B. Why it will be the element of B, Nana? Why? Because it is said that A subset B none. So whenever you have A subset B, that means A is the subset of B. That means each and every element of set A is present in B. That means here only we are telling that. So each and every element of A must be in B. That means if small a, that is the element A, is belonging to A, capital A, that means it is the set A, then what can you say, Nana? So A also belongs to B. So you will be having a clear understanding about this when we are solving the problem. So do watch completely. So next, and we can also represent the above statement by using a symbol, Nana. So see here, A subset B. When will be A subset B? If A belongs to A implies A belongs to B. So here I have used one symbol, that is nothing but we call that one as implies. So how to write this one? That is nothing but implies. So see here, A subset B. A will be subset of B when if A belongs to A. That means there is an element which is belonging to A and also it should belong to B. Okay, Nana? So that is nothing but implies. So if A belongs to A implies A belongs to B, then what can you say here? That is nothing but A subset B. If each and every element is not present in B, for suppose each and every element of set A is not present in B, then what can we say here? We can say that A is not a subset. So you know that how to represent belongs to means we will be representing like this, and does not belongs to means just will be writing the symbol and will be striking it off. Clear, Nana? Here also you will be doing the same thing. If each and every element is not present in the other set, so what can you say that? So A is not a subset of B. Just write the symbol of subset and then you strike it off. Then that will be like not a subset. Okay, Nana? Not subset of. Okay. If it is like this, A is a subset of B, and if it is like this, A is not a subset of B. Okay, Nana? Clear? I hope this concept is clear for you till now. Okay, look here. For example, if A to be subset of B, if A to be a subset of B, that means each and every element of A must be present in B. Each and every element of A must be present in B none. Clear? But so sometimes we can see that whether each and every element of B is also present in A. Right, Nana? So let us take an example and then it will be clear for you. For example, when will be A subset B, Nana? For example, I am taking a set here, that is A is equals to. So in this set I have 1, 2 as elements, and in set B, if I have 1, 2, 3 elements, 1, 2, 3 elements. So see here, each and every element is present in B. So each and every element of set A is present in B, then you can represent it as A subset B, Nana. A subset B. Sometimes, okay, sometimes the sets may be like this, 1, 2 and B is equals to 2, 1. Let us take like this, B is equals to 2, 1. So this is the other case. Okay, Nana? So see here, each and every element of set A is present in set B. So 1 you have here, in here also you have, and 2 is present in set A, 2 is also present in set B. So what can you say here? So you can say that A is subset of B. Clear, Nana? A is subset of B by the definition. Each and every element of set A is present in set B. And also you can also observe here, each and every element of set B is also present in set A, right? So 2 is present in set B, 2 is also present in set A, 1 is present in set B, and 1 is also present in set A, Nana. So 1 is also present in set A. So what can you write here? So you can also write B subset A, right? So by the definition, each and every element of set B is present in set A. Therefore, B also will be the subset of A. So if each and every element of set A is present in set B, then you are telling that A is subset B. So see here, Nana, here you have two conditions. A is subset of B and B is subset of A. A is subset of B and B is subset of A. So this is possible only when, so what kind of sets are these? So observe here, in the previous class we have discussed, if two sets are having same elements, then the sets are equal sets. So this is possible only when A is equals to B, Nana. It is possible only when A equals to B. Clear? So this is the condition. If A subset B and B subset A, then what can you say, Nana? So A and B will be what here? Equal sets. So this also we can symbolically represent it as A subset B and B subset A. So here I am using one more symbol. So these symbols are very important. A is equals to B, Nana. So this symbol has two arrow marks. In the previous symbol we have used implies, right? Now there we have only one arrow mark to an equal to symbol, you can think like that, but here you have two arrow marks. So this is like double implications. Okay, this is like double implication. So how to read this one? How to read this one means if and only if and only if. So see here, Nana, A will be subset of B and B will be subset of A when these two conditions will be satisfied. If and only if A is equals to B, if and only if A is equals to B, only if the sets are equal, then A will be subset of B and B will be subset of A. So see here, so here you can say that A is equals to B, right, Nana? So here the sets are equal, therefore A is subset of B and B is also subset of A. Clear? And sometimes this complete statement can be written in briefly as just IFF, Nana. So IFF is also having the same meaning, that if and only if. So how to write the statement here? A subset B and B subset A if A is equals to B. A subset B and B subset A if and only if A is equals to B. So see here these two terms are having the same meaning. Clear, Nana? These two are having the same meaning. And you can also see from the right side also, if A is equals to B, if A and B are equal sets, so what can you say about subsets, Nana? So if A and B are two equal sets, then A will be subset of B and also B will be subset of A and also B will be subset of A. So this is about the double implication symbol, right, Nana? Let us see the previous case once again. So see here, there we have two sets, that is A and B. In set A we have the elements 1, 2 and also in set B we have the elements 1, 2. So each and every element of set A is present in set B. So what can you say here? That is A subset B. That is A subset B, right, now? So but actually if you observe, A is equals to B, right? A is equals to B. So both are the same sets. So in place of B, what can you write now? In place of B you can write here A. Clear? So what can you represent here? That is A is subset of A. A is subset of A. So from this symbol, what can you say here? Every set will be the subset of itself. Every set will be subset of itself. This is very important. Okay, every set will be subset of itself now. And also you can take a null set. For suppose also you can take a null set. So in null set you will be having no elements. In null set you have no elements. So here also you can say that null set will be subset of every set now. Null set will be subset of every set. So see here these 2 points are very important. Every set will be subset of itself and also null set will be subset of every set now. Why? Because in the null set we don't have any elements here, right now. So you can say that what is the definition of subset actually? Each and every element must be present in other set. So here we don't have any elements only. So you can say that null set will be subset of every set. This is very important point. Don't get confused here. Null set will be subset of every set here. Okay, Nana? Right, Nana? Let us look at some examples here. So see here, the set Q of rational numbers. The set Q of rational numbers is a subset of real numbers or not? The set R of real numbers. So what is he telling that? So Q is the set of rational numbers and R is the set of real numbers. So what can you say here? So obviously Q will be subset of R or not? Q is nothing but set of rational numbers and R is nothing but it is a set of real numbers. So you will be knowing, you knows that every rational number is a real number or not? Every rational number is a real number. Clear? So that means each and every element of Q is present in R. Therefore, what can you say here? That is nothing but Q subset R. So this is everything. This point everybody knows. And let us look at the next one. That is, if A is the set of all divisors of 56. If A is the set of all divisors of 56 and B is the set of all prime divisors of 56. Okay, if A is the set of all divisors of 56 and B is the set of all prime divisors of 56. So let us check whether there is any relation like subset or not. So for that reason, what we need to do? Just convert them into roster form, then that will be easy for us. So how we will be representing the set A here? So that is nothing but it is the set of divisors of 56. Set of divisors of 56. Divisors in the sense that is nothing but factors. So 1 is a factor, 2 is a factor, 4 is a factor, 7 is a factor, 8 is a factor, 14 is a factor, 28 is a factor, and also 56 none. So what are all the factors of 56 here? That is nothing but 1, 2, 4, 7, 8, 14, 28 and 56. Clear? And let us go for the next set, that is B. So what can you say here? B is the set of all prime divisors of 56. So if you do prime factorization, then you can easily find out what are the prime factors there. So only 2 and 7 will be the prime factors or prime divisors of 56 now. So what can you say about A and B? So once you observe B is the smaller set here. So let us check whether the each and every element of B is present in A or not. So see here now. So in B we have 2, in A also we have 2, in B we have 7, in A also we have 7. So each and every element of set B, each and every element of set B is present in set A. Okay, now each and every element of set B is present in set A. So what can you write here? So you can say that B is subset of A. So you can say that B is subset of A. Let us go for the next one. So here A is equals to 1, 3, 5. Directly it is given in the roster form. And B is the set of all x such that x is an odd number less than 6. Odd number less than 6. So convert this into roster form. So what happens here? So your B will be like 1, 3, 5. Why? Because these are the odd numbers and less than 6. Odd numbers and less than 6. So once you observe A now. So in set A you have 1, 3, 5. In set B also you have 1, 3, 5. So what can you say about A and B here? Each and every element of set A is in B. So that means you can say that A is subset of B. And also you observe here each and every element of set B is present in set A. Clear? So you can also write it as B subset A. So if A subset B and B subset A, what happens? So this is possible only when A and B are equal sets. So from this you can say that A equals to B. A is equals to B. So in third case A and B are equal sets. So let us see the next one. In set A you have the elements as A, E, I, O, U. These are nothing but vowels and these are the first 4 letters of the English alphabet. So that is A, B, C, D. Now what can you comment on A and B? So here B is the smaller set. Why? Because we have only 4 elements here and A is the bigger set. We have 5 elements here. So let us see each and every element is present in set A or not. So see here now. In set B we have A, in set A also we have A, and in set B we have B, but we don't have any B in set A. So what is the definition of subset nana here? Each and every element of set A must be present in set B, or each and every element of set B must present in set A. So here that condition is not satisfying. Therefore you can say that B is not a subset of A. B is not a subset of A. So with this I think you have understood the concept clearly now. So let us learn about some important terms, right Anna? Let us understand one more concept here. For example, if A subset B and A is not equals to B, A subset B and A not equals to B. So what can you say about A and what can you say about B means here we have 2 important terms that is very important. So here each and every term is important. You should know the meaning of each and every term, each and every symbol also. So see here. So let us take an example and let us check here. So see here I am taking A as the set which we have only 2 elements 1, 2, and I am taking B here, that is 1 comma 2 comma 3, 1 comma 2 comma 3. So according to the given condition, A is subset B or not, so each and every element of set A is present in set B. That means here you have 1, here also you have 1, here you have 2, here also you have 2. That means each and every element of set A is present in set B here. So you can say that A is subset of B. A is subset of B none. So see here, just for our simple understanding, you can simply say that this is the smaller set and this is the bigger set, right? So here you are telling that A is the subset, right? A is the subset, and if it is not equal to B, if B has some extra elements, so you can say that it is nothing but it is like proper subset. So now what can you say here, Nana? A is the proper subset of B. A is the proper subset of B. So both should not be equal. When A and B are not equal, then A is like proper subset. Okay, for example, the sets are like this: x 1 comma 2 and y is also 1 comma 2. So here also you can represent x is subset of y, right? And here also you can represent x is subset of y, but here x is not the proper subset. X is not the proper subset here. Clear now? X is not the proper subset. Why? Because x is equals to y. So here what is the condition? You can see now x is equals to y, but here, so A is not equals to B. A is not equals to B. Whenever two sets are not equal sets, then the smaller set and A subset of B, then you can say that it is the proper subset. And what about B here? So B you can call it as superset of A. This is nothing but superset. So what can you say here? B is the superset of A. A is the proper subset of B. When the sets A and B are not equal. And you know one more thing also. For example, there is a set C such that it has only one element 3. So what do we call it? So the set which contains only one element is known as what here, Nana? That is singleton set. So what do you call it? That is nothing but singleton set. So see here you have learned about 3 concepts. These are very, very important. What do you mean by proper subset? So if a set is subset of some other set and both are not equal sets, then you can say that the smaller set is like proper subset and the bigger set is the superset. And the set which contains only one element, is known as singleton set. This we have already discussed in our previous classes itself. Clear? And I hope you have understood this concept very well. So in our next coming classes, we will be taking some examples and also we shall try to solve some exercise problems related to this concept. This concept is very, very important, no doubt. Subset concept is very, very important. You should have complete grip over subset. You should know that every set will be a subset of itself. Null set is a subset of every set, and what do you mean by proper subset and what do you mean by superset, like that. Clear? So you should understand all these things. So once to watch repeatedly. If you don't understand any concept here, if you have any doubts also, you can do comment in the comment section. Okay, if you like my class, please do like it and share with your friends, and don't forget to hit the bell icon to get notifications of our coming classes. Okay, let us meet in our next class. Till then, bye.